Welcome students. I am here to give the lecture for CSC 2 for the subject Engineering Mathematics 2. As in my previous lectures I have discussed with you the test, small sample test as well as large sample tests. First of all, I would like to give you the review of all those tests. Basically we have discussed the three tests. The very much first is Z test, second T test, and the third test is F test. So what are these basically tests are meant for? First of all, I will discuss with you, then I'll start with the chi-square test. So first of all, we have discussed the two types of samples, that is the large sample and the small sample. In case of large sample, we know that the sample observations are greater than 30, and for applying any kind of test, like to test the significance of difference of mean, to test the significance of difference of standard deviations, and for the population proportions we use the Z test. And then we dealt with those kinds of samples whose size is less than 30. So the sample which is having size less than 30, we consider that sample as the small sample. And for that small samples, the basic applications that we discussed, the test of difference of means, then we have discussed the test of difference of standard deviations, and then we have also discussed the significance of difference of the correlation coefficients. For these applications or for testing these kinds of things for small samples, we applied the T test. After that, we have also discussed one more test, that is F test, which is also known as variance ratio test. This is the test which is also applicable for the small samples, that is the samples having size less than 30. And the basic application of F test is that if I want to check the equality of variances of two population, or in other words we can say that is there any significant difference between the variances of two samples or the variances of two population, in that case we use the F test or variance ratio test. So these are all the summary of the tests that I have discussed in my previous lectures through video. Now the last test that I am going to discuss with you, it's a chi-square test, C-H-I, chi-square test. And the symbol that I have used for chi-square, you can read from your screen. This is the symbol for chi-square. So the chi-square test was basically given by Karl Pearson. We have also discussed Karl Pearson's coefficient of correlation. So he was a statistician who has also introduced chi-square test. So this is the test, it is also called the non-parametric test, that is the test which is independent of any kind of parameter. As I have told you the parameter and statistic in my previous lectures when we discussed the sampling theory, I told you when the constants used for sample, they are known as the statistics, and if the constants which we use for the population or the large size of sample, that is known as the parameter. So here the chi-square test is a test, it is also called non-parametric test because we don't make any assumption regarding the population parameter. That's why the chi-square test is also known as the non-parametric test. Now this test is basically measures the degree of discrepancies between the observed and the theoretical frequencies. Basically in this test we will evaluate the two factors, observed frequency, which will be already given in the question, and we will evaluate the expected frequency, and it will vary for each and every question. How to evaluate expected frequency, I'll discuss with you when we will do the numericals. So the chi-square test basically, or the basic application of chi-square test is just to discuss or just to tell what is the basic difference, what is the scatterness of the, or the degree of scatterness between the observed frequency, that is the frequency which is already given in the question, and the expected frequency. So it is used to determine whether the discrepancy so obtained between observed and theoretical frequencies is due to error of sampling or due to chance. As I am telling you, that is the frequency which is already given in our numerical or in our question, that is considered as the observed frequency, and expected frequency we will evaluate. So there will be some discrepancy, or there is some different values. All the values will of expected frequency, they will not match with the observed frequency. So what is the functioning of chi-square test? The functioning of chi-square test is just to tell the degree of discrepancy or this differentiation between the observed and the theoretical values, and it will also tell us that this kind of discrepancy, if occurs, what is the reason behind that? That is whether it is due to some error, that is some mistake in our sample, or it is just by a chance. And if there is some mistake, then what is its quantity of the error? So the chi-square statistic that I used, you can read from your screen this formula. We used sigma OI minus EI whole square over EI. Now what is OI? OI means observed frequency, which is already given in the question, and EI is the expected frequency that we have to evaluate that. So first of all, I will evaluate OI minus EI, then its whole square, then I will generate the next column OI minus EI whole square over E, and then summing up that, then I will get the value of chi-square. I'll tell you that how to calculate these things through the numerical, through the upcoming numericals. So what will be the conclusion? Definitely we will take the degree of freedom here as n minus 1, where n is the sample size, that is the number of observations given in our sample. So again we will calculate the table value and the calculated value. So if calculated value is less than the table value, then null hypothesis will be accepted, and if your calculated value is greater than the table value, then the null hypothesis will be rejected. Now one more observation is there for chi-square test. If the value of chi-square statistic is positive, it means OI and EI, means observed frequency and expected frequency, they completely coincide, or they agree exactly, they are having the same values almost. But if your chi-square is negative, if your chi-square statistic comes to be negative, then they do not agree exactly, they are opposite to each other. So these are the basic conclusions of chi-square statistic. Now there are some conditions for validity of chi-square test, about which you must know. The very much first is the sample observations should be independent, they should not depend upon each other, their choice should be random from the population. Second, summation of observed frequency and summation of expected frequency, they should be same. And then we are having capital N. Capital N means the summation of the frequency. The total frequency should be large, say greater than 50. It should be greater than 50. And also no theoretical cell frequency, it should be less than 5. In case if the value of the cell is less than 5, then we will use the pooling method. Now what is the pooling method? I will discuss with you later on. When we will deal with the numericals, I will tell you that what is the pooling method. Basically I will give you the idea. Regarding pooling method, we used to add or subtract some quantities. We used to add some value of that cell to that cell which is having the value less than 5, and I will subtract that value from the other cell. Condition is that the summation should not be changed, the summation should be constant. So these are the basic conditions of the chi-square test. Now what are the properties of chi-square test? The basic properties of chi-square test you can read. The very much first is it is always positively skewed. As I have discussed with you, skewness, positive skewness, negative skewness, it is positively skewed. Means mean should be greater than median, should be greater than mod. The number of degree of freedom is the mean of the chi-square distribution. Whatever be the degree of freedom, that will be the mean of that chi-square distribution. And the value of chi-square is always positive, that it always lies between 0 to infinity. Then the value of also chi-square increases with the increasing degree of freedom. As the sample observations, if we increase them or the sample size n increases, the value of chi-square also increases. That is, there is a positive relationship or there is a direct relationship between the values of chi-square and the degree of the freedom. That is the one value less than the number of observations in the sample. And the last property is the shape of chi-square curve depends upon the degree of freedom, but it is not a symmetrical distribution. So let us discuss the chi-square distribution for that how it is applying in the numericals. So the very much first numerical I am going to discuss with you. the question is that the following table gives the number of accidents that take place in an industry during various days of week. Test if accidents are uniformly distributed over the week or not. That is the number of accidents throughout these 6 weeks, whether they are almost same or they are different. So here I will apply the chi-square test. So we are having the data. I will read the data for you. On Monday the number of accidents are 14, on Tuesday it is 18, on Wednesday it's 12, Thursday 11, Friday 15 and Saturday is 14. So as we know, the very much first step of our testing is to set up the null hypothesis. So the null hypothesis in this case will be, let the accidents, they are uniformly distributed over the week. So this is the first application of chi-square, that is if I want to check the uniformity of the data, then I will use the chi-square test. So what will be the alternative hypothesis? It will be the complement or the opposite statement to the null hypothesis, that is the accidents are not uniformly distributed over the week. So now the days we are having Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. The number of accidents frequency is given to you. So this is your observed frequency. It will be denoted by OI. Okay, 14, 18, 12, 11, 15 and 14. Now I will generate the column EI or E, expected frequency. As I have taken my null hypothesis that the accidents are uniformly distributed over the week, so means the number of accidents on all these 6 days, they are almost same. So the expected frequency, how you will calculate it? You will add sum of OI, you will add them 14 plus 18 plus 12 plus 11 plus 15 plus 14 and then divided by the number of the days, that is 6, which comes to be 14. So next I will generate the column O minus E, observed frequency minus expected frequency. That is 14 minus 14 0, 18 minus 14 minus 4, 12 minus 14 minus 2, 11 minus 14 minus 3, 15 minus 14 1 and 14 minus 14 is 0. Then you will take its square, O minus E whole square, 0, 16, 4, 9, 1, 0. And then you will evaluate the final column, which is named as O minus E whole square over E. You will divide the each and every entity of O minus E whole square by E, that is 14. So I am getting, if I am adding up them, I am getting the answer as 30 by 14. Now what is the chi-square statistic? As I have discussed with you, it is given by sigma OI minus EI whole square over E. O means observed frequency, E means expected frequency. So it is 30 by 14. If I divide them, I am getting it as 2.1428. You can verify it also. Now I will evaluate its table value. Again students, I am telling you, if the value, if the level of significance is given, then it's okay, you have to follow that. But if it is not given, then by default you can take it is at 5% or 1%. It's your choice. Usually I used to take 5%. So at 5% level of significance with degree of freedom n minus 1. So n, the number of days is 6, 6 minus 1 is 5. The table value comes to be 11.09. You can verify it or you can calculate it from the tables. Now I will evaluate or I will make the comparison of the absolute calculated value with the table value. Now the calculated value is 2.1428 and the table value comes to be 11.09. So since calculated value is less than the table value, so therefore H naught is accepted, means null hypothesis is accepted. It means the assumption that I have taken is correct. So it means that the accidents, they are uniformly distributed over the week, means the number of accidents throughout these 6 days, they are almost same. So this is the one of the application of the chi-square test, that is if I want to check the uniformity of the data, then I use to apply the chi-square test. There are so many more applications of chi-square test which I will discuss with you in my upcoming lectures. So hope so the lecture is, the content through this lecture that I have delivered to you is clear to you. If you have any kind of issue, please ask me, and please read it thoroughly. This is the last test of your, according to your syllabus, that I am discussing with you. So this is the chi-square test. So hope so you are having the full-fledged clarity of the concept or the contents that I have given you through this video. And if you feel any kind of doubt regarding this lecture, so you can call me, you can make me WhatsApp, or you can Gmail me. You can ask your query through me at any time. Thank you so